Okay, welcome back, everyone. Let me just catch you up if you didn't watch sort of my disaster yesterday. Um, so day 10 is a fun little challenge. It's got some graph traversal in it, and then you make a pretty large graph. The second part is traverse the graph. I had a brute force solution. It turns out the graph is pretty big. I left it running overnight. I woke up this morning and it still hadn't finished. However, I also woke up this morning knowing how to solve this without the brute force. And so the brain is a pretty crazy thing. And given the time that we call this incubation, I actually talk about this in my learning course. If you give it time to get away from something, it can often come out with the right solution. And so let me just talk about what I think is a solution that won't be brute force that will allow us to finish this. Let's talk about the data structure that we have. We have a graph that's implemented as a dictionary. So it's going to start at node 0, and then every key in that dictionary are the nodes that we go to. And we want to count how many paths we can go through this graph to one final node at the end. So what I did was yesterday I just traversed this whole graph, and it turns out that it gets pretty big, and so that traversal takes a long time, and I just counted however many times I saw the N through my traversal of that, and it hadn't finished this morning. So the insight I had is that we have this graph represented as a dictionary. How can we calculate the paths through it? Well, what we can do is we can go through each node, and in this case, you know that the nodes are always incrementing, so that actually helps. So you can go through the nodes incrementing one by one, and at the first node, we're only going to have one path through it. And then if we split and we go to two nodes from that, each of those nodes will have path 1, but when they combine back, what we're going to do is we're going to sum up the paths in there. So when we have like some diamond structure, the node where those join will have the sum of the counts above that. So if there's one path through this way and one path through this way, when we join those will have 2. And then we'll just repeat that. So we can actually implement that pretty straightforward. All we have to do is loop over the lowest value to the highest value, and if it has parents, we start keeping the track of the counts for each node, and we sum up the counts of the parents. So in order to do this, what we need to do is we need to make what's called an inverted index, or we just need to flip the dictionary around. Right now we're mapping a node to its children. What we need to have is another dictionary that maps a child to its parents, and it can have multiple parents because you can have this diamond shape. And so first we'll implement that. So let's implement that. So I'm going to say def inverted here, and it's going to take a graph, and so I'm going to call this a graph, and then I'm going to make a result here. I'm going to say that the result is equal to, and then what I'm going to do is I'm just going to say for parent comma children in graph, and I spelled children wrong, graph.items, and then what I'm going to do is I need to have res take a child and map it back to its parents. Now, because multiple nodes can come to the same child, I need to make sure that I don't overwrite that. So what I'm going to use is I'm going to use a feature of the dictionary called setDefault. I'm going to say res, and I'm going to loop over my children for child in children. And then I'm going to say res set default. I'm going to set the default for the child to be a empty list. So what this will do is if there's already a value in there, or if there's already a key of child in res, it skips it. If there's not, it just initializes that to a list. And then what we're going to do is we're going to say res, and then we're going to say child. That's going to give us the list, and then we're going to say append. So the list might be empty the first time, or it might not. And I think this should invert it. Let's just return res at that point. I'm going to come over here to my test and test the inversion here. So here, let's start off with the simple case here. So here is test sample 2, input part 2 real. So this one worked with my brute force here. I've got this res, which is my graph here. Let's just do an assertion here. I'm going to say assert inverted res is equal to, and I'll just make an empty dictionary, then I'll inspect it and make sure that it makes sense. Okay, so I've got my inverted here, and I don't have inverted, so I better go do day 10 here. Whoops. Okay, and it says use VV, so let's do verbose here and print out the whole thing. Okay, so here it is. So 1 has a parent of 0, and if you look in there, 0 is always the root node, so yeah, there's 1, and then the next one after 1 is 4, and so 4 has a parent of 1, and 5 has a parent of 4, awesome, 6 has a parent of 4 and 5, very good. So this is looking like it is correct. I'll just copy this here and plop this in here and do a query replace. I'm going to replace this with this. Okay, so I think our inversion works. Okay, so that looks like it's working. Okay, so now I'm going to make this function called count traversals. So I'm going to say count traversals, and it's going to take a graph. And what I want is I want to get the inverse of that. So I'm going to say inv is equal to inverted graph. And I also want to make another dictionary. This other dictionary is going to keep track of the counts at each node. Okay, so I'm going to say counts, and I'm just going to seed that. I'm going to say let's seed at 0, node 0, the count is 1. There's one path through 0. You have to hit 0. Okay, and then what I'm going to do is I'm going to do a for loop. I'll say for I in range, and we'll do, we want the maximum value in this. And so I'm going to say max of graph, which is the keys in there, plus 1. So we want to get that maximum value there, so we need to do the plus 1 since range follows a half open interval. It doesn't include the final index, so we want to include that. Okay, so I'm going to say if we're going to look for I in our inverted. So if I not in inverted, then we'll just continue. Okay, and so at this point we know that I has parents, and so we want to get the count for that. So I'm going to say that the parents is equal to invert of I, and then the value of counts for I should be the sum of the parents. And so I've got the parent indexes right here. I need to pull out the counts for each parent from the count. So I'm going to say counts P for P in parents. Okay. And I think this should work. We'll just return counts here. And this should give us a dictionary with every index, the count of how many possible paths are through that. Let's just make sure our tests run, our tests do run. And then what I'm going to do here is I'm going to assert that day 10 count traversals of res, and I'll just again do this lazy thing. I'll set it equal to an empty dictionary here, and then I'll test it and see what it comes out as. Okay, and so so I got the count traversals. Okay. Res, count traversals, res. So, oh, I think So this is my code that I did previously. Let me just get rid of this here or comment this out. So this morning when I had this thought, my power went out. So while my power was out, I actually tested this here. Okay. So it says here that the count traversals takes one positional argument, but 3 were given. Let's look at for my other count traversals here. Count traversals. Okay, should be good here. This is on what line? 101. Okay. Oh, that's my old brute force version. So yeah, that's my brute force version. Okay. So count traversals takes one positional argument, but 3 were given. Line 101. You got to comment out 101. Okay, and count is not defined. Comment out that. Okay, and we got an error here. It says if I not in inverted, and yeah, so this should be I not in, not inverted here. Inverted is a function. This is my inverted graph. Maybe I could change the name of that. Okay, and so here is what we got back at position 0. There's one path through it. Position 1, there's one. At position 4, there's one. At position 5, there's one. But then both 4 and 5 go to 6, so that gives us 2. And 7, you can reach 7 from 3, 5, and 6. So you sum up those, that gives us 4. 10, you can reach from 7. 11, you can reach from 10. 12, you can reach from both 10 and 11. So that's 8. 15 from 12, 16 from 15, and then 19. So I get 8 as the result here. So what we want to return here is counts, max of counts. And that should give us 8. Okay. Okay, so that is the right answer there. So we'll just take this little snippet of code here. We have this larger input. Let's test that here. I believe it should be this value here, 19,208. I'm going to make it fail here. Let's just make sure that it fails and validate that we get the right answer here. Okay, and we did get 19,208. Awesome. You'll note that that ran really quickly here as well. I've got, so why do I have this printing in here? Let me just look and see where I'm printing. Okay, so it looks like I'm just printing here. Okay, so I think we're good here. What I'm going to do now is let's do the power move here. So this, here's the big boy that didn't want to finish yesterday. And so this is the code that I had yesterday. And let's just do a assert count traversals of this res, and we'll say it's equal to 0. It shouldn't be equal to 0. This should return pretty quick here. Okay, and we got, that doesn't exist, so it did return really quick. Put day 10 in there. Okay, and this is the answer I got. Look at how quick that was. Awesome. Let's throw this in here. Now this is hard to read again. I'll just use my little hint here. You can use underscores to separate those. And I guess the answer is 1 trillion. Let's just validate that that is the right answer here. So I'm going to go to Advent of Code, go to my day 2 here, and let's put this in here and submit, cross fingers. Awesome. And you know what? I didn't even show my code. Okay. So I feel bad. I just did that all just talking here and not showing my code here. Maybe I should do this again showing my code. But here is my code right here. Inverted is taking my dictionary and looping over my parent and my children, and then count traversals is just getting my inverted graph, seeding my counts there, and then looping over that. So yeah, this was kind of washed. I wasn't sharing my screen. I apologize for that. So maybe I'll do this again, sharing my screen here one more time. This is like going to be the 3rd time I've implemented it today, but I feel like this has been a good challenge. Okay, so thanks for watching. I'm going to actually do another broadcast where I show it.